Hello everyone, welcome to Maths with Mr. J, and today I'm going to teach you standard form. We are going to talk about the meaning of standard form, we give example, and we move further to talk about multiplication, division, addition, and subtraction of standard form. Then let's move forward. What is standard form? Standard form is of the form a times 10 raised to the power of n, where a is number less than 10 but greater than equal to 1, and n is equal to integer. Integer is positive or negative numbers. Now, example 1. Write 240,000 in standard form. Solution: we are going to write 240,000 of the form a times 10 raised to the power of n. Now, a is telling us that the number must be less than 10 but greater than or equal to 1. Then we have to make 240 to be in between 1 and 10. To make it to be in between 1 and 10, the decimal point is here. We move this decimal point from right to left or backward, and we count 1, 2, 3, 4, 5. We are moving it 5 times. Therefore, this will be equal to 2.4 times 10 raised to the power of 5. Now, 2.4 is less than 10 and greater than or equal to 1. Now, evaluate this for me. This is your homework. Write 58,000 in standard form and leave your answer in the comment section. Then we move to example 2. Express 4.834 times 10 raised to the power of 9 as ordinary number. Solution: 4.834 times 10 raised to the power of 9 means we have to move this decimal to the right side 9 times. That is 4.834. Moving it 9 times means we have to move this decimal to the right, from left to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. We fill the gap with 0. Then finally, our answer becomes 4,834,000,000. This is the answer. Then I will give you homework. You leave your answer in the comment section. Then we move further and take another example. I'll call this example 3. Inputting 0.0001 in standard form. Standard form is of the form a times 10 raised to the power of n. And a must be a number which is equal to 1 and less than 10. Then we have to move the decimal point so that this number will be in between 1 and 10. If we move the decimal point, we are going to move it from left to right. How many times? 1, 2, 3, and 4. We are moving it 4 times. That means moving from left to right will give us negative power. So this will change to 1.8 times 10 raised to the power of minus 4. So if we are counting from right to left, the power will be positive. Now I'll give you another homework. You drop your answer in the comment section. Then we move forward and take example 4. Now we are expressing 1.6 times 10 raised to the power of minus 6 as ordinary number. Solution: it's already in standard form. We are taking it back to number. So what we do, we write 1.6 times 10 raised to the power of minus 6. To put this in number, we have to write 1.6. Because it's negative power, we are counting from right to left. So we write 1.6. We are moving this decimal point 6 times backward. We have 1, 2, 3, 4, 5, 6. So this will be equal to 0.1234 5, and 6. So let's write it clear. We are having 1.6 times 10 raised to the power of minus 6 is equals to 0. We have how many zeros after point? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then 1 and 6 as the answer. Now I'm giving you homework for you to do and leave your answer in the comment section. In continuation, we are going to look how to multiply and divide standard form. Example 1. We take that of multiplication first. Now we look at example 1. It says find 2 times 10 raised to the power of 3 multiplied by 6.75 times 10 raised to the power of 5 without using a calculator. Give your answer in standard form. Solution. Then we continue. This is the same thing as 2 times 6.75 in bracket times 10 raised to the power of 3 times another 10 which is raised to the power of 5. Now, in law of indices, since they have the same base, we have multiplication law of indices, which states that whenever we have number of the same base, which is a raised to the power of m times a raised to the power of n, we can express this by taking one base, then we add up the power, which is m plus n. And if this is true, we are going to apply it here. Then we continue. If we multiply 2 times 6.75, we are going to have 13.5 times 10. If we apply law of indices, we are having 10 raised to the power of 3 plus 5. Then we continue. Here, 13.5 is not in standard form. Standard form tells us that the number must be in between 1 and 10. So to put 13.5 in standard form, it will become 1.35 times 10. Because we move the decimal point backward once, it becomes times 10 raised to the power of 1 times 10 raised to the power of 8 when we add up the numbers. If we move further, this is the same thing as 1.35 times. Here we have to apply multiplication law of indices above again. This will be 10 raised to the power of 1 plus 8. And finally, we are having 1.35 times 10 raised to the power of 9 as the answer. It looks a little bit tricky. Now I am giving you homework. Leave your answer in the comment section. Then we move further and take another example. Now we take example 2, which is division of standard form. Now calculate 240,000 divided by 4.8 times 10 raised to the power of 10. Solution. We write down 240,000 divided by 4.8 times 10 raised to the power of 10. First step, we have to change 240,000 to standard form. Changing 240,000 to standard form, we have to count the decimal point. Starting from here, we have 1, 2, 3, 4, 5. Then we are having 2.4 times 10 raised to the power of 5 divided by 4.8 times 10 raised to the power of 10. We can express this as 2.4 times 10 raised to the power of 5 all over 4.8 times 10 raised to the power of 10. Now we can split it, or we leave it this way. If we split it, we have 2.4 all over 4.8 times 10 raised to the power of 5 all over 10 raised to the power of 10. Now we can express this as 2.4 into 2.4 gives us 1, and 2.4 into 4.8 gives us 2. So this is the same thing as 1 over 2 times. Then in division law of indices, where we have a raised to the power of m divided by a raised to the power of n is equal to a raised to the power of m minus n. The power of the numerator will minus the power of the denominator. If this is true, we are going to apply it here. And if we apply that, we are having 10, we take 1 of the base, then raised to the power of 5 minus 10. If we continue, we can change 1 over 2 to decimal. If we change 1 over 2 to decimal, it becomes 0.5 times 10 raised to the power of minus 5, because when we say 5 minus 10 gives us minus 5. Then we look at this expression. 0.5 is not in standard form because it's a number less than 1, and the rule says that standard form must be a number in between 1 and 10. Then expressing 0.5 in standard form, 0.5 will change to 5 times 10 raised to the power of minus 1, because we are moving the decimal point from left to right once. Then times 10 raised to the power of minus 5. Now, this will be equal to 5 times 10. If we apply the multiplication law of indices, we state that whenever we have a raised to the power of m times a raised to the power of n is equal to a raised to the power of m plus n. And if that is true, we apply it here, then it becomes 10 raised to the power of minus 1 plus minus 5. And that is the same thing as 5 times 10 raised to the power of minus 1 minus 5, because plus minus gives us minus. And finally, we have 5 times 10 raised to the power of minus 6 as the answer. Now, I'm going to give you homework. Drop your answer in the comment section. Add and subtract standard form. Example 1, calculate 9.8 times 10 raised to the power of 4 plus 6.6 times 10 raised to the power of 3 without using calculator. Give your answer in standard form. This is a bit tricky. We say solution. What we do, we write out the numbers, which is 9.8 times 10 raised to the power of 4, all in bracket, plus 6 times 10 raised to the power of 3. What we do, the first step we do, we look at the numbers times 10 raised to the power of 4 and times 10 raised to the power of 3. They are not equal. We have to make the powers equal. To make the power equal, we have to make one of the numbers to be power of another one. Either we reduce power 4 to 3 or we increase power 3 to 4. But I choose to increase power 3 to 4. To increase this power of 3, 10 raised to the power of 3 to 4, what we do, we have to move this decimal point here once from right to left. Then it will change to 9.8 times 10 raised to the power of 4, all in bracket, plus 0.66 times 10 raised to the power of 4, because we've moved the decimal point once backward to give us 1, which make the power to become 4. Then we continue. We can rewrite this to be 9.8 plus 0.66, 10 raised to the power of 4 is common, or times 10 raised to the power of 4. Then if we add the number in the bracket, we are going to have 10.46. We are not using calculator, but let me do it so you can see how I did it. So in this case now, we have to write 9.8 and 0.66. We fill this gap with 0. If we add this together, 0 plus 6 gives us 6. 8 plus 6 gives us 14. Carry 1. We put the 1 here. 1 plus 9 gives us 10. That is how we arrive at this point. Then times 10 raised to the power of 4. We look at this. Is this expression in standard form? No, it's not in standard form. What is the rule of standard form? Rule of standard form is telling us that where A must be a number less than 10 but equal to or greater than 1. And if that be, we have to rewrite this in standard form. And if we write 10.46 in standard form, we are going to have 1.046 times 10 raised to the power of 1, because we move the decimal point from right to left or backward, times 10 raised to the power of 4. And we record the law of multiplication of indices. The law that says that whenever we have the same base multiplying each other, we have to add the powers, which is a raised to the power of m times a raised to the power of n is equals to a raised to the power of m plus n. And if this is true, we are going to apply it here. And if we apply that, we are having equal to 1.046 times 10 raised to the power of 1 plus 4. And finally, we have 1.046 times 10 raised to the power of 5 as the answer. Now, I'm going to give you one as homework. You solve it and leave your answer in the comment section. Now, we move further to subtraction of standard form. We take example 2, which will be talking about subtraction. Now, example 2 is talking about subtraction of standard form. Calculate 3.28 times 10 raised to the power of 12 minus 7.12 times 10 raised to the power of 10. Solution. We write 3.28 times 10 raised to the power of 12 in bracket minus 7.12 times 10 raised to the power of 10. Now we look at the base 10. Both of them are not equal. If they are not equal, base 10 here is to the power of 12 and base 10 here is to the power of 10. We have to make 10 raised to the power of 10 to be 10 raised to the power of 12. How do we do that? We continue by writing 3.28 times 10 raised to the power of 12 minus, to make 10 raised to the power of 10 to be 10 raised to the power of 12, we have to move the decimal from right to left 2 times to meet up with 12. Meaning we have to move the decimal point from here 1 and 2. So we can get the power 12, which is equal to 0.0712 times 10 raised to the power of 12. I skip a step. By now you know what I'm doing. Now the power and base 10 are equal. This is equal to, we write the numbers, we pick the numbers, which is 3.28 minus 0.0712 in brackets times 10. Since 10 raised to the power of 12 is common, we bring it out. Now, if we subtract 3.28 minus 0.712, we are having 3.2088 times 10 raised to the power of 12. Is it in standard form? Yes, it's in standard form. So we leave our answer like this. I know you will ask me, how do we get 3.2088 without using calculator? I will explain it here. That is, if we want to solve 3.28 minus 0.0712 without using calculator, this is what we do. We write 3.28 minus 0.0712. We make sure the point is of the same vertical line. Now we fill this gap with 0. 0 minus 2 is cannot. We borrow 1 from here, left with 7. If we add that 1 to this 0, it becomes 10. Then from 10, we borrow 1, left with 9 here. Then we add that 1 to here, it becomes 10. 10 minus 2 gives us 8, left with 9 here. 9 minus 1 gives us 8, left with 7 here because we borrow 1 initially. 7 minus 7 gives us 0. 2 minus 0 gives us 2, and 3 minus 0 gives us 3. That is how we got this. So now I'm going to give you homework. Then you leave your answer in the comment section. This is GCSE exam work question. Is application of standard form to real life situation. Light traveled approximately 1.86 times 10 raised to the power of 5 miles per second. The distance from the Earth to the Sun is approximately 9.3 times 10 raised to the power of 7. How long will it take light to travel this distance? Give your answer in standard form. Solution. This is where mathematics interwove with physics. Light traveled approximately 1.86 times 10 raised to the power of 5 miles per second, which is the speed denoted by capital V, is equal to 1.86 times 10 raised to the power of 5 miles per second. Then the distance from Earth to the Sun is approximately 9.3 times 10 raised to the power of 7, which is distance denoted by capital D, is equal to 9.3 times 10 raised to the power of 7 miles. Now, how long will it take light to travel this distance? Give your answer in standard form. Then we are talking of time denoted by capital T, which is not given. In physics, speed is equal to distance over time, which is V equals to distance all over time. Now, if we make T the subject of formula, T becomes D all over V. Then T becomes, distance is given as 9.3 times 10 raised to the power of 7 all over, speed is given as 1.86 times 10 raised to the power of 5. If we continue, we can split this into 2, which is 9.3 all over 1.86 times 10 raised to the power of 7 all over 10 raised to the power of 5. If we apply division law of indices, where we have a raised to the power of m all over a raised to the power of n is equal to a raised to the power of m minus n. If this is true, we apply it here. That is equal to 9.3 divided by 1.86 will give us 5 times 10 raised to the power of 7 minus 5. Finally, this will give us 5 times 10 raised to the power of 2 seconds. Always remember to put the unit. This is our final answer. If this helped, please subscribe, like, and share. Thank you.